a lab scientist, I'm sure you know the following scenario. You basically go to make a solution from a solid and you accidentally add too much solid or you overshoot the volume. And then, well, you have to consider, do I want to make a whole new solution or can I fix the one I have? And so today, let's talk about how you can fix things if you have too much mass or if you have too much volume for what you were planning to make. Speaking of planning to make, I wasn't planning to make this video, but then I messed up a solution and then thought it was a great teaching opportunity. Not only that scientists make mistakes, but that we can fix these things. And so we were able to successfully correct and fix the solution, and then the bottle broke. But if the bottle hadn't broken, it would have been a happy ending. And so let's talk about how we can fix solutions. There are a couple of different scenarios that you have to think about, and so let's take them one by one. The first is kind of the simpler one to fix, is that you weighed out too much. Maybe you miscalculated and then you realized afterwards you miscalculated and that you had too much solid in there. No worries, just add a little more of your solvent. But how much of your solvent? Here what you need to do is you need to basically just take your measured grams. So if you have a solution, you have a concentration in gram per liter. Maybe you got it starting from the molecular weight and taking the molecular weight times the molarity you want and to get your grams per liter. More on that in other posts. But today we're starting, we know what we want in terms of grams per liter. We just weighed out too much grams. Okay, well now we have to just figure out the new total volume. So we have to take the measured amount we have in there and then just divide it by the desired grams per liter. The grams cancel out, nice and happy, and then you get the liters that you need, and then you know how many liters you currently have, so you subtract the current volume from your needed total volume to get the volume that you need to add. But if you're doing this, basically, it's always better to, what we're calculating is the final volume, and so if you're doing things in like a graduated cylinder, then just adjust the volume to that point. Speaking of that, one of the reasons why you might find yourself in a situation where you have too much volume is because you were just adding the calculated volume of liquid to an amount of solid and forgetting that solids that take up space. And especially if you're doing something like we're going to need to adjust the pH, well, that acid or base that you add, that's going to take up space too, and so you need to account for that. And so that's why you should always prepare your solution in a partial volume that you want. So like take a beaker, dissolve the solids in the beaker in a partial volume, like 2/3, 3/4 of your final volume. Once it's all dissolved, put it into a graduated cylinder, or if you really need to be specific, you can do things in like a volumetric flask. But basically then what you want to do is you're going to want to take it to the final volume. And remember, don't keep that stir bar in there when you're doing that. But that way you are basically, the final volume is what you want rather than what the volume that the solids take up or that you have the extra acid or base that you added. And so it's really, really easy to kind of like go over volume that way. Or even if you're just like filling it up and then you go over when you're like, because you're trying to take it directly from the spout and then it goes over the volume. But you can fix it. Just add a little extra solid. So if that solid, the amount of solid that you need to add is going to be enough that it would actually change the volume appreciably. Like if it's just a little bit of solid that you need to add, it's not really going to change the volume, at least not to an extent that you'd care about, no biggie. Just add that solid. If, however, that you do need to add a lot and then it would change the volume, or if you really, really, really need it to be super duper precise, well then what you can do is you can actually calculate to make an even higher volume than you currently have, so that you have enough room to add both the solid and the liquid. Because typically the liquid's going to take up more space than the solid, and so you can basically say you wanted to make 100 mils, we'll go over an example, but if you want to make 100 mils, you accidentally overshoot it to 110, maybe you could go ahead and calculate for 125 and then just adjust the mass and then the volume to that volume that you want. So basically, you need to adjust the, if you have too much solvent, you need to adjust your mass to match. And so if it'll change the volume, then you need to go ahead and do that higher volume. If it won't change the volume, well then just calculate it out, weigh the amount you need, which is going to be the amount you want minus the amount you have, and that's going to be the amount that you need to add. So sometimes you don't even know if it would be like enough to change the volume until you calculate out how much you would need. And so if you calculated out how much you need, well, then you're going to have to recalculate with a higher volume, but you got to calculate it first in order to really kind of know. Or if you know that you have like a really, really big fluffy solid and stuff, then you might need to do that. Or if you really overshot the volume. Okay, so that is that. And now let's go and look at an actual example. Okay, this wasn't the example we messed up, because the example I messed up was kind of like weird. But basically, this is a more simple example. Say you want to make 100 mils of 100 grams per liter solution. So if you're working in a lab a lot, you get really used to converting between liters and milliliters by just moving your decimal place 3 points, because there's 1,000 mils in a liter. So I can kind of go off my head and just know that 100 mils is going to be equal to 0.1 liter. But you can go ahead and dimensional analysis yourself out. So 100 mils times 1 liter is 1,000 mils, and that would give you the 0.1 liters, and then you multiply that by 100 grams per liter, and you end up figuring out you need 10 grams in 100 mils. Okay, a couple ways we can screw this up. One is we had more than 10 grams, and the other is we have more than 100 mils. So let's start with the easier one. We put in 11 grams instead of 10 grams. What are we going to do? We're just going to figure out how much solvent we need to add. Basically, we need to add enough solvent so that the final concentration is still going to be that 100 grams per liter, because that's what we care about. So we say, okay, we know that we have 11 grams. We want to find X, our volume that we need. So we take it to equal 100 grams per 1 liter. So basically, we can then do X equals, we just multiply X over here, and then we're going to have to divide by that to get that X by itself. So we find that X is equal to 11 grams over 100 grams per liter. The grams cancel out. I love canceling things out. Dimensional analysis. Okay. But anyway, 11 grams divided by 100 grams per liter, and that's going to give us our 0.11 liters, which again, 1, 2, 3 moves to the decimal place, we get 110 milliliters. So this is the volume we want to adjust to. And we know that the volume that we have was the 100 volumes that we made. And so now we say, okay, well, we have 110 that we want. We already had 100, and so we need to add 10 more. But again, this is one of those things where if the really best practice is to do it in like a graduated cylinder, because we want that to be the final volume rather than the volume that you need to add. And so typically, if you're adding this liquid to a liquid, you're not really going to change the volume much, because unless they're like interacting with one another. Still, best practices, do it that way. Some liquids really do interact with one another, so like ethanol and water and all that. More on that in another video. Alternatively, what you could do is you could calculate the volume and just for the extra amount that you have. So we say, okay, well, we have 1 gram extra. 11 grams minus 10 grams, we have 1 gram extra. And then we can basically say, okay, well, that 1 gram per X, 1 gram divided by X equals 100 grams divided by per liter. And then X is equal to 1 grams over 100 grams per liter. And that gives you your 0.01 liters, which again, 1, 2, 3 moves the decimal place. And then we end up with, say, needing 10 mils, which is what we calculated before. So we know that we're going to need 10 more mils. And so that's one way to do it too. Okay, so now let's say we weighed out correctly, but we accidentally got our volume to 110 mils. What are we going to do? We're going to calculate how much we need to add. We're going to figure out if the amount that we would need to add mass-wise would change the volume enough that we really care. And if it does, then we'll go to a bigger volume. But let's just start with figuring out how much we would need if it wouldn't change the volume. Okay? So we say X divided by 0.11 liters equals 100 grams per liter. We calculate out X is equal to 100 grams per liter times 0.110 liters, and X is 11 grams. Yeah, I chose the same kind of like opposite situation as before so that the numbers would kind of like match. Anyway, we want 11 grams. Now we already had 10 grams, so we need to add a gram. Now, if the addition wouldn't significantly change the volume, we just add the gram directly. But if we worry that the gram is going to increase the volume above that 110 grams, that 110 mils that we already have, which is already too much, then we need to make even more than too much so that we can add both the grams and the volume. So the solvents. So let's say, okay, let's go ahead and calculate to make 125 mils. Well, then we would do x divided by 0.125 liters, which again, 125 mils. 1, 2, 3 move to the decimal place will give us 0.125 liters. X divided by 0.125 liters equals 100 grams per liter. We get that X is equal to 0.125 liters times 100 grams per liter. X is equal to 12.5 grams. So again, we have 11 grams. We need 12.5. 12.5 minus 11 is 1.5 grams. So we need to add 1.5 grams and then adjust the final volume to 125 mils, or 0.125 liters. So, hope that helps. Know that you can typically fix the solutions when you mess them up, although sometimes, depending on how expensive the thing is and how much of a hassle it would be to remake it, sometimes it's just easier to remake it. But especially those times when it's something that's like really tedious to make, or you used a lot of the reagent, or you're out of the reagent, whatever, just go ahead and fix it. It's really better for the environment, better for your wallet, better for your brain, because you get to do all this fun math. So hope it helped.